So at any point in time, if you feel free to do that. Right, so this is meant as an interactive session. Hoping I have some questions there. Excellent. Okay, let me know when you can see my screen.
Yes, we can see your screen, Tej.
Okay. Awesome. Okay. How many of you saw this headline this morning? Okay. So I don't know if you saw this, but this happened yesterday. So I saw the headline this morning. So 1.7 million smartwatches are being recalled by Fitbit because of a burn hazard. So apparently, burns and obviously potential explosions, etc. So they've been recalled. Nothing as major as this has ever happened to us, but not too far off, I would say. Right. So these are the sort of things that can go wrong at scale when you scale IoT devices, obviously. And what I'm trying to do today in the talk and over the next couple of weeks, perhaps, is go a little bit deeper into what are the sort of things that we've learned from the mistakes that we've made. What are the things that we do today, and what you could do to make your scale journey a little bit less embarrassing. Okay, so that's my goal here. So my goal is to try and help you scale your IoT products with less embarrassment. Because trust me, there's always embarrassment when someone else uses your product for the first time, or perhaps sometimes for the 10th time, right? But we can save ourselves a lot of shame and a lot of trouble, and obviously a lot of commercial loss by avoiding a few specific things and by doing a few specific things. So with that, let's dive in. So our biggest scale rollout was this product called Juve. Juve is a Californian company. They make these devices called light therapy devices. Light therapy is where people use red, infrared, sometimes blue light for various health benefits. Some of them proven, some of them supposed. We won't delve into that too much, but we actually worked on this product here that you see on the right. It is the Juve version 2. And every single Juve version 2 device that was shipped, and that's a little over 50,000 odd devices, has our remote IO controller inside. Each of these units sold for between $800 to $1,200 per unit. So these were not low cost units. They were very, very high value products. Right? And we made possibly every mistake that we could have while shipping these things. Some of them were mitigated, some of them could not be. So I'll describe those as we go along. Okay, so if I may, first thing, right, off the top of my head, this is the biggest mistake that we made, OTA plus recovery. Right? I'll go into what this means. Obviously, OTA is something that if you're building an IoT product, you probably are aware of, right? So OTA stands for over the air, and over the air primarily from a perspective of updates, right? Our phones receive over the air updates all the time, right? We are notified that, hey, there's an update available. The download size is, I don't know, 500 MB. This will take 20 minutes to install, and you'll be able to reboot, or you'll have to reboot post installation. Now, for a phone or for a device which has a display and which is used by a user and can the user can interact with these update notifications, etc. OTAs are actually pretty simple to manage. What you need is the ability to upload an OTA file to some server somewhere, and the ability for your device to connect to that server and look for updates. And the ability for the device to download that file and install on itself. So from a technical perspective, an OTA is actually not that complex. It is pretty complex, but there's been enough work done that today it's essentially a commodity solution, right? There are entire companies built just around OTA. I can't remember specific names right now, but there's a bunch of them, right? So if you use one of their services, then your OTA is taken care of and you don't have to worry about it. For Juve, we did not use one of these services. The customer was keen on keeping costs as low as possible. and things happen. So for clarification, as I mentioned, Juve was the brand based in California that sold these products. Our customer was not Juve directly. Our customer was actually an OEM in China who was subcontracted by Juve to manufacture. And we were selling our IO modules to that OEM. And we had implemented a couple of different ways of doing OTA. One was using a remote server, and that used GitHub Pages URL, mainly because for whatever reason, when we used an S3 bucket, the OTA kept failing. And because our involvement was, at the relatively basic level that, hey, here's a working system, now you make modifications to it yourself. We implemented it with GitHub Pages. We gave it to them. It worked fine. But we're given them clear instructions that they should probably not rely on that GitHub Pages OTA forever, and they should implement a server of their own. We gave them a spec for what that task, what that server would look like, what does the file structure, what is the URL, blah, blah, all of that sort of stuff, right? They did not migrate from GitHub Pages to their own server. 2 years later, GitHub changed their SSL certificates. And with that, because at that time, we had to pre-embed the server SSL certificate into the client, into our devices. Once GitHub changed their SSL certificates, remote OTA would no longer work. Now, we had anticipated that there could be potential issues with remote OTA, and we had very cleverly implemented something called a local OTA. And so we had a accompanying app for this as well. So the app could act as an OTA server, and the device could access the OTA itself. Then it turned out that at some point in the change revision history of this firmware, someone had added these two lines to the left, // which meant that everything about the OTA existed. All the code was there, the Bluetooth coordination, the app side of it, everything worked. But we were not even starting the OTA task. So we were not actually able to do an OTA from the phone. And this had completely passed us by. And because this was done from a shared computer at the OEM site, we had no way of knowing who had actually done this. And obviously, someone had to carry the blame for this. So we ended up carrying the blame for this, even though this is 2 years after the initial involvement and we hadn't been involved in the product development for a year and a half by this time, right? It was already there. They'd already fabricated, manufactured and sold 45,000 devices by then. But these two / marks and the GitHub SSL fiasco essentially meant that there are now a little over 50,000 Juve version 2 devices out there in the world, which can never get an update again, unless there's a physical recall. Because then obviously you can do a physical connection and do an OTA, which obviously wasn't likely to happen, did not happen, and rest is history. Consequences of this were that the OEM lost the contract to actually manufacture Juve. I don't think solely because of this. There were lots of other issues between the OEM and the brand. We continue to be on good terms with Juve. We actually have helped them subsequently with various things as well. But we also decided that we would never ever build a service again without first focusing on OTA and making sure that that piece of code is locked in and does not change. So these days, one of the first things that we implement, this is literally, I think, line 3 in a new product that's under R&D right now. So this is written in MicroPython, which is what we use typically for our R&D products. Line 3 or line 4 starts with this. If a button is pressed during boot, go into a factory reset mode. Okay, and I cannot stress enough how important this piece of code is. Just yesterday, we were at a client site where we had done an data. You make some mistakes and you're like, oh, okay. But we were able to recover because we just pressed a button, reset the device, and we were back at factory firmware. And then from the factory firmware, we were able to do it. So these, 5-6 lines of code, if you remove the print statements, etc., these are probably the most critical pieces of code that you will add to your firmware ever. And now, I appreciate the reset buttons on routers, etc., and so on, much more, having faced these issues so many times. So my first learning at scale was essentially make sure your OTAs are robust and fail-proof, and have a factory reset mode always. Because even in the Juve case, if there was a factory reset mode that we could go back to, we could have started an OTA again from there, right? So the only thing the factory reset mode really needs to be able to do is do an OTA. If you can do that, then you're okay. You need to have functionality, that's fine. Because step one, you ask the user, hey, great, factory reset done, now do an OTA. Right? So this is one learning. Second, okay, before I proceed, any questions on this? I'm happy to take. If not, then I'll wait for questions in the chat. Okay, I can see the chat questions, so I'll wait for that. And feel free to, by the way, as an interrupt me with voice as well. That's perfectly fine. Okay. So second is visibility and feedback. And this, I struggle to pick right words for this, but what do I mean by this, right? So at some level, visibility, all I mean is first, from a user's perspective, a user interface, right? The Juve is a headless device. Okay, so what I mean by that is there's only really a small 7-segment display on it. There's, where it shows a time. So it's on, it's running for a period of time. It shows you how long is remaining. That's it. Now with a 7-segment display, you can't really do any notifications. You can't really do any debugging. You can't give the user any feedback if there are errors. So one of the first things for headless devices is to implement a simple user interface, and it doesn't have to be glamorous, right? So look at this; it's pretty basic. There's nothing very fancy about this, but it allowed us to connect to the device over Bluetooth and see progress as well as get error messages over Bluetooth, right? This actually is a critical thing because you need to allow the users to be able to report errors back to you. So if you have a headless device, I would strongly urge you guys to build an app where a user can also report errors. So the device needs to be able to obviously show a user interface, or the app needs to be able to show a simple user interface, which should also be able to capture some basic errors from the device, show error codes if you're using error codes, and have the user be able to send those back to you as a developer with a one click. Because most don't really understand, what's going wrong. So giving them a simple way to report errors back to you will save you a lot of trouble. Right? So that's one part of it. That's the user side of the visibility. Second part of the visibility is for you as a developer, right? And this is a nice looking Grafana dashboard. It doesn't need to be nice looking, right? It just needs to be functional. I would always, if your device has the ability to connect to the internet, urge you to set up a very, very basic, cloud server. It could be Elasticsearch, which is my favorite. Could be anything else. Could be a custom service as well, where you can send as many log messages as you can. So for our part, Juve was built on top of AWS IoT. So we used AWS IoT. Juve would send messages to AWS IoT, and from there we would stream them into Elasticsearch and store them, right? And there are two immediate benefits to this. First, you can proactively react to errors, right? If you see error messages coming back from the device, that in this particular case, it was a pretty simple device. You could switch between red, infrared, or both, and set a time, right? There's not really that many ways to go wrong. Even then, sometimes things do go wrong, right? So you can sense those sort of things remotely. In this particular one, we had a temperature sensor, so we could actually internally monitor the temperature of the device and see if it's getting too hot. Because it's a pretty high power device, it is about 700 watt. So having a temperature sensor helped us debug a few potential issues. But most importantly, one of the things that we learned, and we probably learned it a little too late, again, because we weren't necessarily involved. We set it up and we handed over when we got out of it, right? But for today, for all of our devices, we are very proactive about this. Of the 50,000 plus devices that Juve sold, only 1,000 ever connected to Wi-Fi. So Wi-Fi was such a non-existent feature for the users that it was entirely pointless to try and bake in Wi-Fi or use all those other features, etc. That's one perspective. The other perspective is that if you know this well in advance, then you can actually invest some time in marketing and explaining to the users why you want people to use Wi-Fi, right? And how it's beneficial for their usage. Because you also obviously getting some data from it and you're able to, prioritize features in a request for the next version. You're able to diagnose issues, handle warranties better, etc. So imagine, as in, what is that? That's 2% of all devices ever connected to Wi-Fi, right? Even then, we were handling about 20 million messages every month, right? So even just across those 1,000 devices, we were handling a ridiculous number of messages every single month. And I'll delve on that into that a little bit deeper later. But there's a second thing. So first thing, visibility for your user. Second thing, visibility for yourself. Both of these are critical. And doesn't need to be fancy. It can be simple because these are easy to update over time. Your user will not complain if you give them a simple app and then update it over time. They'll actually be happy because you are optimizing their experience. And a simple app which connects on Bluetooth and shows some basic buttons and so on, captures error logs, shouldn't take that long to build either. Next, coordination. This is a little bit trickier. Okay, we already found one bug in coordination today with this event, right? So that happened. But I don't know how many of you remember this. So by training, I have a PhD in wireless engineering. My profession is antenna design. I used to be antenna design before I got into startups and everything else. But when this happened in 2010, I was a fairly conceited antenna designer and I laughed at like, okay, they clearly have idiots designing antennas for the iPhone, right? Because quite honestly, no self-respecting antenna designer who's half skilled would have designed the antenna that the way they designed it for the iPhone. It was pretty stupid. It was actually very, very stupid the way they did it. But it turns out, and I read into this, read a bit more about this eventually, and turned out that it wasn't the antenna designer's fault. The antenna designer said that this antenna will not work. He was overruled. He was overruled because they'd already made all the other industrial design considerations, which meant the antenna could only be the way it was designed, right? Or the way it was selected. So the antenna designer wasn't stupid, the industrial designers were. But that's often the case. And what I mean by that is I'm not saying industrial designers are stupid. I'm saying that different functions will prioritize different things. And as a result, if the coordination is not strong enough or is not aligned enough, you will end up having issues. This happened with the Juve as well. But before I illustrate what happened with the Juve or explain what happened with the Juve, this is what happens to an antenna. Okay, so I don't know if you can see the slide clearly enough, but there's a small antenna, some kind of antenna. Let's not worry about what antenna it is. In free air, when it's in air, the frequency at which it operates is about, let's say, 440 megahertz, right? When it's put on the wrist, which actually doesn't really have that much fat, right? The frequency of operation drops to around 350 megahertz, 360 megahertz. What does it mean in layman terms? Well, it means that if your antenna connects to the Wi-Fi in free air, once you put it on the wrist, it will not connect to the Wi-Fi. Although the frequencies will be different, but the principle remains the same. And this exact thing happened with Juve, where although it wasn't on a body, what they did is that they asked us to design the antenna or pick the modules and put everything together, and that was great. If on the left you see this, dotted panel, that's all metal. So their first position of where to put the antenna was right behind this metal sheet. I was like, whoa, hold on. You can't do that. We had explicitly asked for either a plastic body or an external antenna. So they said, well, we can't change it now. It's too late. We've already fabricated 20,000 of these bodies, so it can't be changed. So they did change it, and they moved it to the other side, changed the mount time a little bit to the other side, and it went behind, a clear picture, this display. If you see on the right side, right, you see the display and the buttons, etc. It went right behind that. So because that was the only plastic section in the entire body, so we're like, okay, fine, that's better. And we were like, okay, that's okay, go ahead and do it. And then next week we had to fly to China on an emergency, because what they did is, even though they put this behind the plastic thing, they turned the antenna around And over the antenna, they had all the wiring of the system going. So the antenna was essentially completely covered by metal. And what that meant in reality was that you had a device which was supposed to work, in this configuration, like 6 units all coordinating together over Bluetooth. And the two corner devices couldn't talk to each other, and they were less than half a meter apart. Okay, like our range was half a meter to a meter. That's how bad it got. And we were just stuck in a place where we were fighting for, okay, well, you can't do this. We had explicitly, this is the email that lays out how the body should be, blah blah blah, whatever. They said, well, it's too late. If this is how it is, what do we do? So at the last minute, we had to refabricate the boards, introduce a wired connection for these devices to be connected together. And we went with a CAN interface. The body at the back, they added a drill hole and added a CAN connector, and we had to use CAN to coordinate between these devices. So suddenly there was a Wi-Fi Bluetooth enabled device, which if you had multiple units, couldn't actually talk to each other. If they were individual and they were far apart, everything still worked okay, because the display, the displays were in a place where there was free air around it, and you could just about get maybe 5-6 meters of range. But when they were stacked together like this, the Wi-Fi wouldn't work. And now this is a problem, because this configuration that you see on the screen, that is $7,200 worth of hardware. Each unit is $1,200 times 6 units, $7,200. So someone's paid $7,000+ for this, and there's no functioning Bluetooth or Wi-Fi on this. But that's how bad it was. And I think I put it down to coordination. Maybe language barriers as well. I don't know, but that was one thing. So why do these things keep happening? As in, these things, shouldn't happen. All of us like to think that we are professionals and we are well educated and well versed in our skill. The reason is that IoT development is extremely complex, right? So I stole this graphic from a company called Cyborg, which seems to do IoT product development. And if you look at it, right, so the number of different skill sets involved in building an IoT product is ridiculous, right? So software developers have it easy because, 1 or 2 skills and you're good. You know how to build a front end, you know how to build a back end, great. You have a product, you can scale it infinitely, awesome. IoT products are way more complex, and that's where the joy is as well, because that's what we enjoyed solving, but also that's where the risk is, right? So one thing that we decided to do is that into 2017, 18, 19, we used to do all of this, right? So every single part of this was done in-house, except the industrial design. We used to outsource industrial design or work with our partners who had industrial designers on their own teams. But today we do very, very few things, and I'll get into that quickly. I just have 2 more slides before I go to questions. Takeaways from doing this. First thing that you implement, this is what the rule we follow today. Implement the factory reset first. It doesn't matter what else you do or don't. Implement the factory reset first, and do not change it. So lock it in. Have measures in place in your Git control that these lines don't change, or implement the factory reset in a separate file and make sure that that file does not change ever, right? Those are simple things that you can do. Apologies, there's a little bit of noise outside. Next, implement the OTA, right? Forget about the rest of the features, etc. We always, as developers, we want to implement the features and then get to OTA and factory reset and those sort of things. My thesis is implement the factory reset, then implement the OTA. Do not program any of your test features over cable, right? Over a micro USB or a JTAG cable or whatever. Deploy everything using OTA, every single feature. And that way you actually find a bunch of bugs with OTA, you find what works, what doesn't work, and you also make sure that your OTA is robust, right? Then you implement telemetry. Okay, so telemetry is basically where you send metrics out to Elasticsearch or whatever server that you want to use. And then at the same time, build a simple user interface, whether it's in your device itself or as an app. Give the user the ability to report some errors, right? This is critical as well. Show them the error, be explicit, at least in the early days. Other things like more, general things, stability is way, way more important than features, right? So building fewer features actually gives you time and ability to, actually focus on the things that work well. For instance, actually Apple does this really well. Apple products are typically under-featured, right? Underpowered, but what works well, barring an antenna. Second thing is, make sure you give yourself enough time. As in IoT these take longer to design and get right. Enclosures take longer. Sourcing takes longer, right? With a war happening right now, things might get pretty bad again. Who knows, right? So then it's uh, everything just takes longer. So give yourself enough time, and then pick the right tools. As in picking the right tools is critical because you could save yourself a ton of effort. So actually, can you just give me a second? I'll just 1 second. Okay, thanks for that. Doesn't believe that to use off the shelf where feasible. Shelf like a pre-built development tool or antennas that are off the shelf instead of building your own, etc. Be conservative in your choices. So one thing not one Juve, but in another product, which is a music device, the deployment entirely happened through Docker. Now, Docker is great for desktop, but this is back in 2016 or 17, and Docker was very, very nascent for ARM devices. And then we ended up with a situation where there were 20 odd, music devices out in the world, where Docker had managed to completely format or remove the file system. And this is a bug in Docker that was discovered later and fixed. But we were left with 20 devices that we had to recall and re-implement everything on over here. So be conservative. So use tools that are proven that you're comfortable with, and it's okay. From a firmware perspective, one thing that I've come to appreciate is understandability is way more important than performance. So if you as a developer understand the firmware and are able to fix issues with it, that is actually tends to be, in the long run, much more important than performance. Now, obviously, there are caveats here. Some things you just can't implement, using, for instance, let's say MicroPython, right? You need performance and you need to go to C. But at least in the early days, I would definitely not recommend going to C directly, unless you're a C ninja, in which case, more power to you. And then focus, right? This is critical. As when you're scaling, it's extremely difficult to scale everything, right? So then, as I said, there's so many different things that an IoT product requires, and we used to do all of this. So one of the things we did as a company, as IoT Ready, was we killed absolutely everything in the company except hardware and firmware. So we used to do web services, backend, cloud, some level of design, UI, UX design, not industrial, et cetera. And we never, really succeeded in doing everything well. I would say we succeeded doing everything cool, right? Over the last couple of years, however, we decided, right, we double down on what our strengths and what our differentiators are, which is hardware and firmware. And we've been able to actually succeed quite well with that, right? So what we do today is we say, okay, well, we don't do apps. We partner with people who do apps, right? Or we go to customers who already have apps and, we partner with SAP or people like Big Basket, et cetera, who have strong software teams internally, right? And they can do the app side of it. And we just focus on the hardware and the firmware part of it. Another thing that we've been doing more diligently recently is to completely separate out R&D and production, right? R&D is when you want to move things fast and you break things, you change things, etc., etc. And then our production cycle is completely different, and we have different people in both of those to the extent possible. And because the way of thinking, the way you approach those problem statements is also very different. So, for instance, in my company, I am the CEO. We don't really have titles, but I'm the CEO. But since I'm also technical, I mostly focus on customer-facing R&D and prototyping, customization, those kind of things. My co-founder, Dr. Jay Warrior, is a CTO, and he doesn't get involved at all on the R&D side of it. He just listens to our inputs, and he leads the team that implements the stable building blocks, and these go into production, right? And this distinction is actually helping us massively, because then we're sure that, okay, well, hey, our server code, API server code that we run on all of our products, every single one of our products uses the same API server code. That is so debugged and has been tested so diligently and at scale that we are dead certain that nothing can go wrong over there. Whereas in the R&D or the prototype side of it, some features that we implement could break at any time and we don't really know. So this distinction is another thing that, helps you scale a bit better, because you can just sleep, rest more easily that, okay, these things will work well. So that's me for this week. This is the overview of what are the main things that we've learned from our mistakes. If there's anything else that you guys think we could have done differently or better, I'm happy to listen to, or also obviously take questions. I don't believe we have a ton of time, but we have about 10 minutes. Over to you guys.
So if any of you has any questions, please feel free to put it in the chat box, or you can raise your hand. You can use the raise hand feature.
Okay, so there's a question here that did your product being GPS-based location coordinates, any challenges there that one should be aware of? None of the products that we've worked at IoT Ready, but on GPS in my past life. And simple things like range in GPS can vary quite dramatically, right? Understand your environment, where you're putting the antennas, where what are you. I have experience of in GPS. GS piece of code that handles firmware frame for a GSM chip. It has a simple tool for you to add about
Tej, your voice is not really audible. I'm not sure whether it is the same with everyone.
so as I said, okay. Yes. For a couple of now, yeah. Typical costs that you for your certification range from about 3 to 4 lakhs per product category. So one thing that people typically see, we have a consultant, certification consultant who's working with us on that. He,
sorry to interrupt. Your voice was breaking up in the middle. So if you could repeat for the
again.
I'm sorry to interrupt. Like your voice was breaking up in the middle. So
Okay.
if you can repeat, like probably that might give a better clarification to
a lot of chaos. My dog's just seen something and he's going off on something as well. So just give me a second.
Sure.
I can do that. Okay. So can you guys hear me now?
Yes, now it's perfect.
Okay. All right. Okay. So I was saying that I'll start on the certification question. So certification, we have a consultant. We are putting a couple of our products through certification right now. Certification costs can be as high as not as high as, and they typically are between 2.5 to 4 lakhs, depending on the complexity of the product and number of tests that are required, etc. And certification is painful in the sense that there's a lot of documentation. Your consultant will typically tell you what you need to do, etc. Your enclosure design needs to be pretty robust and it needs to work well. Then obviously the tests, the claims that you're making in terms of your electrical safety, all of that needs to be tested properly. So that's fine, as in the lab takes care of all of that and you have a few chances to iterate and improve that. Thankfully, we've not had to, we've been okay. But one thing that typically consultants will tell you, and this is something that we learned, is that if it's possible to group your products so that there's a master product and other products are derivatives of it, certification becomes a little bit simpler, because you don't have to certify every single derivative product. You can certify the master product and the others are sort of covered. Now, I don't necessarily know how kosher this is, but it's well enough. The consultant says this is fine and this is what everyone does. So I'm going by that. Now, with certification, there are two types. There's the self-certified, which is what we are going through. So it still costs about 3-4 lakhs, as I said, the consultant fee plus the testing fee, etc. And there's also the external lab certification. So for instance, someone like a UL underwriter's lab can certify your product, right? And that obviously tends to be a lot more expensive. I don't have costs for that, but I wouldn't be surprised if it's closer to 10-15 lakhs or so. At the minute, our products don't require that, so we haven't gone down that path. More questions? 1 second. Recommendations for good off-the-shelf antennas. Oh wow, okay. There's a bunch of companies. There's a company called Laird in the UK, LAIRD. Their antennas tend to be pretty kick-ass, really good. There's another company called the Antenna Company. I think it's a Dutch company. Yeah, I think Antenna Companies is what they're called. Their antennas are pretty good. We work with a couple of Chinese vendors for our RFID antennas and Wi-Fi antennas, etc. They're pretty good. The only problem with importing antennas is that it gets pretty expensive. So you pay $1,000 for the antenna, you pay $1,000 for shipping, you pay another $500 for whatever 30%, 600 rupees for customs. So your costs grow up massively. However, on the other hand, there's no really any good Indian antenna manufacturers. We have tried a couple of them who claim to be manufacturers. What we found is that they're just importing and reselling, so which defeats the purpose. We've tried doing our manufacturing ourselves because we do have the skill to design the antennas. It's just unless you're doing it at scale, the pricing doesn't really work out. And there are certain kinds of antennas that you can't really design. So for instance, ceramic antennas, which is what you typically use for GSM or GPS or RFID. There's not really that many places in India that can manufacture it. ISRO can, but then it's a slow process and they don't do large volumes. So any other questions, guys?
Or any other questions from anyone else? I think that's all the questions for the sessions today. So with this, we come to the end of this session. And I would like to thank the speaker, Tej Pochiraju, for this wonderful session again. And I'm sure audience finds the same. So with this, we conclude today's session. And thank you everyone.
Yeah, no, thanks, guys. And if you have any recommendations for topics that I could deep dive into, because this was obviously a very quick overview, feel free to share it with me or with the organizers, and I'm happy to dive into it. Okay, all right.
Yes,
Thanks.
yes,
Have a nice day. Cheers. Bye.
Thank you everyone.